Hello everyone, welcome back. Today we're going to be talking about slopes of lines. Hopefully you remember this from 7th and 8th grade. We're just going to go over a few things that we need to know. So first of all, when we started talking about a number line, it was just this one-dimensional line, and you actually just started talking about the negative numbers in 7th grade. Then as we moved from 7th into 8th and so forth, we started talking about this in terms of an XY axis. So here we'd have the X axis, then we'd have the Y, and then we learned about plotting those things. So, but underneath this graph is really something that is called, it's really important actually, it's called a lattice point. So I want you to take a look at this picture and try to think of how it differs from this picture. So on this one we have lines. So when we talk about graphing and finding the slope of a line, it's really important that we look for these lattice points. So the lattice points would be underneath all of the intersections of these lines. You can think of this as a whole bunch of little dots underneath here. Okay, I'm not going to make every single one of them, but that's what that previous picture was showing you. So when we go to choose points to figure out a slope, we would be looking for our lattice point to be going through maybe some of those lattice points. So if we take this one for instance, so it's hitting, not up here, but it's hitting a lattice point here, 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 and here. Those are the things that we need in order to calculate slope. So we'll go through a formal definition here in just a second. So slopes of lines. The slope is the ratio of the distance along the y to the distance along the x-axis. So it's important to remember that it's y divided by x. Oftentimes you're going to see this as a formula. You probably remembered this from 8th grade, but it was y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And all those mean are different coordinate points here. So this would be my x sub 1, y sub 1. Here is my x sub 2, y sub 2. So notice here that the 2's go together and the 1's go together. Another way to think about this, we do this a lot in science, but the change in the y value divided by the change in the x value. We actually talk about this all the way up to calculus. All right, so here I have some examples drawn out for you, and I'm giving you the lattice points. So here the lattice points are given, and you're going to use them to calculate the slope. So let's say I'm going to use these 2 points, which I could use this other point here, and I'm going to fill in this triangle. So remember back when you first started talking about this, we talked about rise over run, which is just change in my y value over change in my x value. So this distance is 2, and then we have 1, 2, 3, 4, 5, 6, 7, 8 there. So we have a rise of 8 and a run of 2, and then I look at that line, and from left to right it's pointing down. So we could reduce this to -4. The next line we're going to do is C. So here we have some points, and again we need to know our rise value over our run value. So here we could just count 1, 2, 3, 4, 5, 6, 7, and we count our run 1, 2, 3, 4, 5, 6, 7, 8. Hopefully I counted right. So it would be rise of 7, run of 8, and that would be your slope. Reading from left to right, this graph goes up, therefore it's positive. Now these other two both have an undefined slope, and an undefined slope, you can think of it as trying to ski off of that. Like, this is not a possible ski hill kind of size. It's not going to work. So we have that those vertical lines are undefined. So here I have a couple. I'd like you to take a minute and just try them. I'm going to press pause, and then we'll check your answers. So I've drawn in some values for you. One thing, again, I'll just remind you, as you read this graph, you start on the left, it's going down, so it's going to have a negative slope. So it'd be -3/5. Okay, if this is a ski hill, and if any of you have skied or snowboarded, this is absolutely no fun, and it has 0 fun, so the slope is 0. And the next one, as we read it from left to right, is going up. So my rise is 6, my run is 3, which we can reduce to 2. And then again, this one, this is not skiable. It's considered undefined. All right, so how we read a graph. Just like we read in English, we read from the left to the right. So you have to look at where is the graph in on the left-hand side. So if a positive slope will always be slanted upward like this. Negative slope will do the opposite. It's going to start and go down. So these are all negative slopes. So this is no fun at the ski hill. You are a 0 slope. You are a horizontal line. And then we have the undefined slope. Not possible. Cannot ski or snowboard that. This would be considered undefined. All right, so we're going to go 2 examples here, and then we're going to be done. So when you read a graph, we did talk about those lattice points. So if we try to find those lattice points, we see we don't really find one until approximately here and about there. So when you're calculating slope, don't just count the boxes when you have real-world application. You need to look at the y values. So if I look at the first y value, my x-coordinate is 0, but my y-coordinate is 50. The other one over here, it's 14, 150. And then we would have to use our slope formula, which is y sub 1 over, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we would get that this would be my x sub 2, and here would be my y sub 2. So we fill in our parts, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So my y sub 2 is 150, minus my y sub 1, which is 50. My x sub 2 is 14, minus my x sub 1, which is 0, and you end up getting 100 over 14.